Close your eyes and feel the weight of your own body. That pressure is gravity, a silent hand pressing you into the earth. Now, expand that feeling 1,000,000,000 times. Imagine a force so massive it holds entire galaxies in its fist. An invisible framework that does not reflect light, does not radiate heat, and does not answer to our laws of physics. We are like ants crawling across a motherboard, feeling the heat of the processor, but blind to the information flying over our heads. The cosmos is not a museum of light. It is a machine made of shadows, and that machine is starting to fail. To understand the true shape of our world, it is not enough to simply look through a telescope. We must take a mental journey. We must forget everything we know about comfort. Forget the warmth of the sun. Forget the hardness of the ground beneath your feet. We must go into exile, to a place where the very concept of distance loses all human meaning. Imagine that we begin to move backward, away from home. First, Earth turns into a pale blue dot, and then disappears entirely. We pass through the orbits of the giant planets, leaving the solar system behind. But even here, we are still at home. We are still in the suburbs. We accelerate. The stars begin to blur into a single stream. We see our Milky Way from the outside, a giant glowing spiral island, rotating in majestic silence. Hundreds of billions of stars, trillions of planets. Every dot of light, there is someone's possible story. But at the altitude where we are headed, even this grand galaxy becomes insignificant. We rise even higher, and now the Milky Way shrinks to the size of a speck of dust. It fades and becomes just one of millions of pixels in the infinite darkness. Here, in deep space, intuition begins to fail us. We are used to thinking that the universe is chaos, that galaxies are scattered in the void at random like stones thrown by the hand of a careless sower. It seems to us that if we fly far enough, we will see only a uniform, boring fog. But that is an illusion. Chaos exists only in our imagination. Reality is subject to a strict, terrifying order. When we reach the scale of hundreds of millions of light years, the darkness stops being empty. A structure begins to emerge from the gloom. At first, it looks like ghostly shadows, but as our eyes adjust to the scale, the shadows take form. This is architecture. This is the cosmic web, the skeleton of reality. Look at this pattern. The first thing the mind feels when meeting it is a deep, almost primal recognition, a feeling bordering on déjà vu. We have seen this drawing before. It is hardwired into our nature. If you take the thinnest slice of the cerebral cortex and magnify it 1,000 times, you will see the exact same picture. Billions of neurons stretching their axons through the void, searching for contact. Or look at the complex network of mycelium beneath the soil in a forest, or the veins in an autumn leaf held up to the light, or the night map of planet Earth, where cities are connected by thin threads of highways. The laws of physics at the macro level are disturbingly similar to biology. Looking at this glowing network, it is impossible to escape the thought that the universe is trying to build the body of some unimaginable organism, as if we live inside a giant brain frozen in a moment of thought. But these threads are not biology. They are gravity. What looks like thin fibers of light are in fact colossal rivers of matter. Astronomers call them filaments. These are the largest structures that have ever existed. Each such thread stretches for hundreds of millions of light years, and they are not static. Inside these threads, motion is boiling. These are gravitational autobahns. Thousands of galaxies, each carrying billions of stars, flow along these invisible gutters. They do not drift aimlessly. They are caught in the current. They slide along these fibers, merging into massive superclusters, into the nodes of this neural network, where the concentration of matter and energy reaches its peak. This is the circulatory system of the cosmos, through which the very life of the universe is pumped pulsing. But this structure has another side, a dark side. Look at the space between the threads. There lie the voids, the great emptiness. These black, perfectly round pits occupy most of the volume of the universe. They look like oceans of tranquility, like places where nothing happens. But in physics, silence is always deceptive. Voids are not just an absence of matter. They are not just holes in the cheese. They are active players. They are monsters. In these zones, space is so empty, so cold and rarefied, that it becomes aggressive. Imagine a bubble of air that rises and expands. These bubbles of darkness work like giant cosmic pistons. They push, they expand faster than everything else, and by their expansion, they literally squeeze matter out of themselves. They attack galaxies, forcing them to flee. All this beautiful glowing web, all these threads and nodes, exist only because the emptiness drove them there. We do not live in a vast free ocean. We live on a thin film of foam, squeezed between colossal inflating bubbles of eternal gloom. It looks magnificent. It looks eternal. We want to believe that this framework was built by someone wise, to give shelter to the stars and to life. But that is only a facade, the outer, varnished shell of the building, the skin of the Leviathan. This picture fascinates with its geometry, but it is silent about the most important thing. It does not answer the question, why? Why do these walls not collapse under their own weight? Who built these invisible scaffolds before the birth of the first star? And why is there more energy hidden in this dead void than in all the burning stars combined? We are looking at the map, but we do not see the territory. We see the effect, but we do not see the cause. And to find it, we will have to stop being passive observers of this beauty. We will have to go down into the engine room. Everything we have discussed so far is only the facade, the outer shell. Right now, we are opening the door and stepping inside the laboratory to take this mechanism apart, piece by piece. The entrance is open, and we are looking for those who are ready to face the truth. Join our ranks and become part of the investigation. And now, let us begin. Human nature is surprisingly predictable. We only trust what we can see. Our eyes are our primary tool for survival. Millions of years of evolution have taught us a simple truth. If the eyes of a predator glow in the bushes, the threat is real. If there is only darkness, then there is nothing there. We carried this biological instinct into science. When we first raised our heads to the sky and began to ask questions, we became hostages of our own sight. For centuries, astronomy was a science of light. To us, the universe was a giant, infinite shadow theater, where the only real actors were the ones standing under the spotlight. We built our entire understanding of physics on one elegant but catastrophically wrong assumption. What glows has weight. It seemed logical. Look at the sun. It is a giant ball of plasma that radiates light and possesses massive gravity. Look at the Earth. It reflects light and also has mass. We created a simple accounting formula. Mass equals brightness. We became cosmic auditors. We pointed our telescopes at distant galaxies and began to count. One star, one unit of mass. a billion stars, a billion units. We meticulously summed up the weight of every glowing cloud of gas, every nebula, every quasar. We had a map of the universe, and it seemed complete. We were certain we understood the rules of the game. We thought gravity was a force created by visible matter. We believed the cosmos was empty, and that the rare islands of stars were the only things in it. To understand how wrong we were, we need to return to Earth. Imagine you are a passenger on a night flight. You are flying over a vast metropolis. You look out the window and see an endless grid of lights below. You see the bright lines of the avenues. You see the yellow patches of residential blocks. You see the red blinking lights on top of skyscrapers. If you have never stepped foot on the ground, if you live only in the sky, you might conclude that the city is made of light. You might decide that these lights hang in the void by themselves. You see the street lamp, but you do not see the concrete pole holding it up. You see the light in a window, but you do not see the brick walls, the steel beams, or the foundation of the building. In the darkness, the entire infrastructure disappears. You do not see the asphalt. The cars are driving on, only the headlights. You do not see the power lines, only the bulb that burns at the end of the circuit. You do not see the sewers, the water pipes, or the steel frames of the bridges. To an observer in a plane, the city looks like a scattering of fireflies in a vacuum, but any engineer knows light is only a tiny fraction of the city. It is a thin, superficial film. The real city, heavy, massive, concrete, is hidden in the dark. The lights do not create the structure of the city. They only illuminate tiny fragments of it. But in astronomy, we did not have an engineer to tell us that. We were those same naive passengers on the plane. We looked at galaxies, at those magnificent spirals rotating in the abyss, and we thought we saw the entire construction. We were certain that stars held each other together with their own gravity, that the glowing mass was the entire foundation. It was an era of supreme scientific arrogance that felt as if we had finished the puzzle. You know that feeling when you are assembling a complex picture? You have the box with the reference, you have all the pieces, and every one of them fits perfectly into place. The sky meets the horizon, the sea meets the shore. The image looks complete. In the middle of the 20th century, physicists felt like victors. Newton's equations worked perfectly. Einstein's theory explained the curvature of space. We could predict the movement of planets for centuries ahead. We could calculate the life cycle of a star from birth to explosion. It seemed the building of science was finished, and all that was left for us was to dust the shelves and refine a few numbers after the decimal point. It was a comfortable time, a time of clear rules, a time when the universe seemed honest. What you see is what you get. We did not know we were standing on the edge of a cliff. We did not know that our perfect map described only 5% of reality. We did not know that all our equations, all our laws of gravity that we were so proud of, were written for a tiny, almost insignificant part of the world. For the cosmetic dust, we looked at the night city and ignored the concrete it stands on, and this blindness could not last forever. Reality always finds a way to remind us of itself, and usually it does not do so with a whisper, but with a scream. The foundation of our confidence has already cracked. We just have not heard the sound of breaking stone yet. Somewhere in the silence of the observatories, in the dry columns of numbers, a ghost has already begun to emerge. A ghost that was meant to show us that we are not the masters of our own house. We are only guests living in a set the meaning of which we have not even begun to understand. Great upheavals in science rarely begin with a loud cry of eureka. In reality, when an old worldview collapses, no one opens champagne. More often than not, a revolution begins with a quiet, confused, uncertain whisper in the darkness of a laboratory. That is strange. That cannot be. Travel back to the end of the 70s. It was a time when astronomy existed in a state of blissful, almost dangerous peace. We were too confident in our formulas. The textbooks were written, the laws were established. It seemed the universe was a solved problem. But in the shadow of those big, comfortable theories, a rebellion was already brewing, and it was not started by a famous theorist in a leather chair, but by an observer and standing in the cold tower of a telescope. Astronomer Vera Rubin was not trying to overturn the world or destroy the legacy of Einstein. She was simply doing her job. She was interested in a task that seemed boring and technical to many. She wanted to map the rotation speeds of spiral galaxies. She wanted to see how stars behaved, not in the bright center, but out there, on the distant, dim fringes, where the galaxy dissolves into the blackness of space. According to the laws of physics, which we had considered sacred since the time of Isaac Newton, there should have been no surprises here. The script for this dance was written 300 years ago. Look at our own solar system. It is a perfect working model of gravity. In the center sits the sun, a giant heavy king who holds everything in his hands. The planet closest to him, Mercury, races along its orbit at a frantic speed, almost 30 miles per second. It has to run that fast to avoid falling into the embrace of the star. Centrifugal force saves it. But the further you move from the center, the weaker the grip of gravity becomes. Gravity is a voice. The further away you walk, the quieter it sounds. Earth moves slower than Mercury. Jupiter is slower still, and distant, lonely Pluto crawls lazily along the edge of the system, completing one revolution in hundreds of years. It is a fundamental law of nature. Speed drops with distance. If you are far from the source of mass, you are required to move slowly. If you try to accelerate in Pluto's orbit, the weak gravity of the Sun simply will not hold you. You will break away and fly into the interstellar void. This drop-off is exactly what we expected to see in galaxies. We thought a galaxy was just a scaled-up solar system, a bright, heavy core in the center, and sparse, light stars on the edges. Vera Rubin pointed her high-precision spectrograph at the Andromeda Nebula. She peered into the suburbs of the galaxy, into those zones where there is almost no light, where rare clouds of hydrogen drift above the abyss. She expected to see the graph curve downward, but when the photographic plates were developed and the data was plotted on the grid, a heavy silence hung in the room. The hand drawing the graph did not go down. The line stayed flat. Stars at the very edge of the galaxy, tens of thousands of light years from the center, were rushing through space with the same mad, violent speed as the stars pressed against the core. The galaxy was rotating like a solid vinyl record, not like a system of planets. This was not just strange, it was physically impossible. It was a direct insult to all celestial mechanics. Let us use a harsh physical metaphor so you can feel the scale of this catastrophe. Imagine you are standing in a field, spinning a heavy stone over your head on a rope. The stone pulls outward. The rope is stretched to its limit. The rope in this metaphor is gravity. It is the pull created by visible matter, all those stars, gas, and dust that we see in the telescope. The faster you spin, the stronger the tension. If you spin the stone too hard, the rope will not withstand the stress. It will snap with a crack, and the stone will fly into the bushes like a bullet. What Vera Rubin saw defied explanation. Galaxies were rotating so fast that the rope of visible matter should have snapped billions of years ago. The stellar mass was catastrophically low. By all the calculations of celestial mechanics engineers, the Andromeda Galaxy should have torn itself apart instantly. The stars should have flown off in different directions, like water droplets from a spinning car wheel. Visible gravity was enough for, at most, 10% of the required strength. 90% of the force holding this giant mechanism together was missing. But the galaxy held. It looked calm, majestic, and whole. The stone continued to fly in a perfect circle, even though the rope we saw was too thin and rotten for such a weight. The first reaction of the scientific world was denial. Scientists hated this result. They said, "This is equipment error." They said, "You calibrated the spectrograph incorrectly." They rechecked the calculations, hoping to find a missing decimal point. They looked for uncounted gas clouds, dead stars, anything that could add weight to the scale of the old theory. Rubin returned to the telescope again and again. She checked one galaxy a second, a tenth. She studied hundreds of objects, and everywhere, absolutely everywhere, the ghost was there. The pattern repeated with terrifying precision. The universe was breaking its own laws, the ones written by men. It was a moment of truth, a moment when we realized that reality had been deceiving us. We were looking at a rotating galaxy, and we were seeing an impossible magic trick. Stars were held in their orbits by a monstrous force, the source of which did not exist in the visible spectrum. Something was holding them. Some colossal, invisible hand had squeezed the galaxy in its fist and would not let it disintegrate. We looked into the black void between the stars, expecting to see a vacuum, but the mathematics screamed at us that the void was filled to the brim, that there, in the darkness, was hidden an invisible framework, the mass of which was 5 times greater than the mass of all the stars, all the planets, all the nebula, and all the humans combined. We called it by the dry term, the Galactic Rotation Curve Anomaly, but in essence, it was an admission of our total blindness. We suddenly realized that the visible galaxy, that beautiful glowing spiral we proudly print on textbook covers, is only a tiny tip of the iceberg. It is only the glowing foam on the surface of a deep, dark, and heavy ocean. Vera Rubin did not just find an error in a graph. She felt the skeleton. She proved that without this invisible framework, our visible, cozy world would simply cease to exist. It would scatter into chaos in seconds, and in that moment, the old, understandable universe, made of atoms and light, died. A new universe was born. A universe where we are only glowing ghosts, and the true heavy reality is hidden in the shadows, where our gaze cannot penetrate. There is a strange pattern in the history of science. When we encounter something that threatens to destroy our cozy world, our first reaction is never excitement. Our first reaction is always denial. The discovery made by Vera Rubin should have been the death knell for the old physics, but instead of admitting that we understood nothing, the scientific community did what anyone does in a state of panic. We tried to find a simple explanation. We tried to fix reality without changing our tools. We told ourselves, fine, there is too much gravity. Galaxies rotate too fast, but that does not mean there is some mystical, ghostly matter out there. It just means there is something we are failing to see. It was the era of the Great Cosmic Audit. And to understand what was happening in the minds of astrophysicists in those years, imagine the work of an accountant for a major corporation. Imagine you are conducting an annual audit. You open the safe, you look at the accounts, and you realize the balance does not add up. In fact, it is a catastrophic mismatch. According to the documents, you should have $100 million. That is the mass we can see, the shining stars, the hot gas, the dust. Those are our assets. But when you look at the actual expenses of the corporation, at how fast the galaxy is spinning, at the force required to keep it from flying apart, you realize those expenses require a capital of 500 million. You do not just have a shortage, you have a hole in the budget, the size of 80%. $400 million have vanished, or more accurately, they are working within the system, but you do not see them on your books. What does a bad accountant do in this situation? He does not run to the police to report an invisible thief. He begins to frantically look for money under the sofa. He tells himself, I probably just did not look hard enough. Maybe some coins rolled behind the baseboard. Maybe we forgot to count the change in the coffee tin. This is exactly what astrophysics did for the next 20 years. We looked for change under the cosmic sofa, hoping it would cover a deficit of millions. We called these candidates for the role of hidden money by an ironic acronym, MACOs, massive compact halo objects. The logic was ironclad and very comforting. We reasoned like this: the universe is made of ordinary matter, protons, neutrons, and electrons, the same dough as you and I. It is just that not all of this matter is required to glow like a Christmas tree. The cosmos must be full of junk. Think about Jupiter. It is a giant planet, but it does not glow with its own light. If Jupiter were flying in the interstellar void, we would not see it. It would be dark, but it would still have mass. Think about brown dwarfs, failed stars that did not have enough mass to ignite. They are heavy, but they are cold and invisible. Think about dead stars, cooled white dwarfs, neutron stars, black holes. Scientists clung to this idea like a life raft. It felt as if we had found the solution. The galaxy is heavy, not because of some magic, but simply because it is stuffed with dark, ordinary substance. We thought billions of invisible planets and extinguished suns were swarming around us, that we were living in a junkyard. It was a comfortable theory. It saved our old world. We did not need to rewrite the physics textbooks. We just needed to buy better telescopes. And we began the hunt. We pointed telescopes at the Large Magellanic Cloud, a satellite galaxy of the Milky Way. The idea was elegant. If our galaxy is surrounded by a swarm of invisible dark bodies, then occasionally one of these bodies must pass directly in front of a distant star. Gravity works like a lens. If a dark object passes in front of a star, it briefly amplifies its light. The star blinks. This is called microlensing. We waited for those blinks. We scanned millions of stars every night for years. We hoped to see a sky teeming with these dark wanderers. We hoped the data would show us that, yes, the universe is stuffed with ordinary, boring, dark baryons, that the accounting balance would finally settle. But the universe laughed at us again. We found these events. We saw the microlensing. We found the brown dwarfs. We found the rogue planets. We found the black holes. We found the change under the sofa. We counted all those rolled away coins. We stacked them up. We totaled them with trembling hands, and we realized we had lost. Yes, dark objects exist, but there are pathetically few of them. Their mass could explain, maybe, a couple of % of the shortage. but it could never close that giant, yawning abyss of 80%. Even if we counted every rock, every asteroid, every atom of cold gas in the universe, we would still not have enough mass to explain why galaxies do not fly apart. The accountant metaphor became terrifying. You turned the whole office upside down. You ripped open the upholstery of the sofa. You found a few cents and some old gum, but the account is still missing millions, and in that moment, a cold realization set in. The money was not lost. It never existed in the currency. You know, the problem was not that we looked poorly. The problem was that we were looking for the wrong thing. We tried to stretch the old reality over new facts, but the fabric was tearing at the seams. We tried to explain the behavior of the universe using the matter we are made of, protons and atoms, but the cosmos made it clear. You are not the main characters of this story. You are not even the extras. You are a statistical error. It turned out that ordinary matter, everything we can touch, see, or smell, is only a thin frosting on the cake. The cake itself is made of something entirely different, something that does not interact with light, something that is passing through us right now, like wind through a fence, without hitting a single atom. We had to admit defeat. The attempt to fix the old model failed. The denial ended. We stood face to face with a fact. Our home is not built of the bricks we see. It is built of ghosts, and these ghosts are not just present, they hold everything. We reached the point of no return, the moment when we had to give a name to this invisible architect. We called it dark matter. But a name is not knowledge. A name is merely a label we slapped onto our fear of the unknown. When all possible explanations are exhausted and the equation still does not balance, science has only one path left, a path that terrifies any researcher. You must admit that the error does not lie in the numbers. The error lies in the very foundation of our understanding of the world. By the beginning of the 2000s, the hunt for ordinary dark objects had reached a final dead end. We turned over every stone in the universe, but found only a handful of dust. The mass shortage was colossal. And then there was silence. It was the silence of acceptance, the point of no return. We were forced to look the truth in the eye. The rope holding the stars together is not made of atoms. It is made of something entirely different, a form of matter that has no equivalent in our periodic table. We called it dark matter, but the name itself is only a semantic trick, an attempt to hide our ignorance behind a beautiful term. In reality, we did not discover a new type of substance. We discovered a new architecture of reality. To understand what this means, we must change the scale of our thinking. We must stop thinking of the cosmos as an empty room where someone placed furniture in the form of galaxies. We need to imagine a construction site. Imagine you are walking through an ancient, majestic cathedral. You see the stone arches soaring upward. You see the mosaics on the dome. You see the stained glass letting in colored light. It seems to you that this stone holds itself up by the force of engineering genius. But any builder will tell you, you cannot build a stone arch in thin air. The stones will fall. To build an arch, you must first erect wooden scaffolding, a crude, ugly, but strong frame. You build the form out of wood, and only then do you lay the stone upon it. The stone rests on the wood. It takes the shape defined by the frame. Usually, when the building is finished, the scaffolding is removed. But the universe is a strange builder. It built the scaffolding, poured the concrete, and left it all exactly as it was. Dark matter is that cosmic scaffolding. It is the primary fundamental structure of creation. It appeared first, long before the first stars ignited. In the first moments after the Big Bang, when ordinary matter was just a hot, chaotic soup, dark matter was already at work. It began to clump together, building giant webs, digging gravitational wells. It created the form, it created the skeleton of the galaxy before there was anything inside it capable of glowing. And then came ordinary matter, gas, hydrogen, and helium, our building material. The gas simply flowed where gravity called it. It flowed into these invisible pits dug by dark matter. It filled the prepared molds, like water filling a pitcher. This is why the stars at the edge of the galaxy do not fly away. They do not hold on to each other. They are not supposed to. They sit inside a giant invisible cloud that weighs 5 times more than they do. The galaxy we see, that glittering disk, is only a tiny speck of light at the center of a massive dark sphere. This discovery turned everything upside down. We used to think that stars were the main characters and gravity was their property. Now, we understand. Stars are just decoration, glowing paint applied to an invisible framework. There is a sense of deep, cold wrongness in this. Imagine you walk up to a mirror, you raise your right hand, but your reflection stands perfectly still. Or, worse, you see the clothes on the reflection moving, but there is no body underneath them. In that moment, you realize it is not the mirror that is broken. It is your understanding of who is real. We, ordinary baryonic matter, turned out to be a minority in our own home. We always considered ourselves the norm. We thought being made of protons and electrons was the standard for existence in the universe. But the numbers are ruthless. We make up only 5%. Everything you have ever seen, everything you have loved, everything you have built, every star in the sky, every grain of sand on the beach, all of it combined makes up a pathetic 5% of the universe. The other 95% is darkness. 27% is dark matter, the cold framework that holds us in its hands. And the rest, well, at that time, we did not even suspect the rest. The admission of dark matter was a painful blow to our ego, but it gave us a model that finally worked. We understood how galaxies gather into clusters. We understood why they rotate so fast. We saw that the visible universe simply flows into the gravitational channels laid down by an invisible architect. It seemed the crisis had passed. We found the missing mass. We fixed gravity. We felt, once again, that we were in control. We thought the worst was behind us. We thought we finally knew how this machine worked. It is heavy, it is massive, and under the weight of all this invisible matter, it should do only one thing: slow down. Gravity is an attractive force. It wants to pull everything into a pile. All this colossal dark mass should be pulling the universe back together, breaking the expansion of galaxies after the Big Bang. We were certain of this. It was logic as simple as a falling apple. If you throw a ball up, Earth's gravity will slow it down. But the universe had one more surprise waiting for us. A surprise that made dark matter look like child's play. We were standing on the threshold of a discovery that would not just complete our map, but tear it to shreds. We thought we lived in a world striving for peace and contraction, but we were wrong. In the darkness, there was more than just the builder. The destroyer was hiding there too. By the end of the 20th century, physicists were beginning to feel confident again. Yes, we admitted the existence of dark matter. Yes, we had to accept the fact that we do not see 90% of the mass of galaxies, but we at least understood the rules of the game. We knew who the main player on the field was. His name is gravity. Gravity is the great gatherer. It is a force that wants only one thing: to connect. It pulls dust into stars. It pulls stars into galaxies. It pulls galaxies into clusters. It is cosmic glue. And since the universe is stuffed with heavy dark matter, the strength of this glue should be colossal. The logic was simple. The universe was born in the Big Bang. That was the initial impulse that scattered matter in all directions. But from that very second, gravity began its work of braking. It pulls everything back. Imagine a car that has accelerated and turned off its engine while driving up a steep hill. It continues to move upward by inertia, but with every second, gravity steals its speed. It slows down. The only question was, how fast are we braking? In 1998, two independent teams of astronomers decided to answer this question once and for all. They were not looking for new physics. They simply wanted to refine a number. They wanted to know if the universe would stop and collapse back in a big crunch, or if gravity was too weak and we would slow down forever, drifting into a cold infinity. To measure this braking, they needed a perfect ruler. They needed beacons in the darkness, and the cosmos provided those beacons. Type 1a supernovae. This is a specific kind of stellar death. Imagine a white dwarf, a dead, dense star the size of Earth, but with the weight of the sun. It steals matter from its neighbor. It greedily eats gas until it reaches a critical mass, and at that moment, a thermonuclear explosion of monstrous, strictly defined power occurs. This explosion is always the same. It is so bright that for a second, it can outshine an entire galaxy. For astronomers, this is a gift from the heavens, because all these explosions have the same power. They work like standard light bulbs. If you see a bright bulb, it is close. If it is dim, it is far away. By measuring the brightness of these dying stars, we can say with perfect accuracy how far away they are and how fast they are moving away from us. Scientists pointed telescopes at the deepest corners of space. They found dozens of these distant beacons. They began to build a graph, expecting to see a beautiful, smooth curve of deceleration. They expected to see the heavy hand of dark matter breaking the expansion of the universe. But when they processed the data, reality broke for the second time. The supernovae were too dim, much dimmer than they should have been. First, they thought of dust. Perhaps there is cosmic dirt hanging between us and these stars, stealing the light? They checked. There was no dust. They thought of an error in the calculations. They checked 3 times. There was no error. The dimness could mean only one thing. These stars were much further away than any model predicted. It sounded like nonsense. How could they have flown so far? The only way to be at such a distance is to move faster. The universe was not braking. The car driving uphill with the engine off was not slowing down, it was accelerating. To help you understand the horror of this discovery, let us return to Earth and conduct a thought experiment. Take a ripe red apple in your hand. Go outside. Throw the apple vertically upward with all your strength. Watch it. The apple leaves your hand quickly, but Earth's gravity immediately begins to pull it down. The apple slows down. It rises higher, but with every meter its speed drops. For a moment, it freezes at the highest point. It stops, and then it begins to fall back into your palm. That is the law. That is how the universe works. Gravity attracts. Now, imagine the same experiment, but in the scenario of 1998. You throw the apple, it flies up, it begins to slow down. Everything is normal, but suddenly, halfway to the sky. Instead of stopping, the apple jerks, and with a wild scream, it rushes upward, gaining speed. It does not fall. It flies into the stratosphere, accelerating faster and faster until it vanishes from sight. Who stepped on the gas? The apple has no engine. It has no wings. The only force acting on it is gravity, which pulls down. Where did the energy come from that hurled it away from the Earth? This is exactly what happened to our galaxies. For billions of years, they flew apart after the Big Bang, obediently slowing down under the weight of gravity. But approximately 5 billion years ago, something strange happened. Someone pressed the accelerator pedal. Someone turned on an invisible engine built into the very fabric of the cosmos. Instead of gathering together, the galaxies began to run away. The space between them began to grow with acceleration. This discovery was so shocking that one of the discoverers, looking at the data, said, "My first reaction was, this is terrible. This cannot be, because it makes no sense." We were looking for dark matter to explain why the universe holds together, and we found it. But now, we have found something even more powerful, a force that wants to tear everything apart, a force that laughs at gravity. We called it dark energy, and that was the moment we realized the universe is not just a mechanism, it is a battlefield. When we realized the universe was accelerating, our first reaction was to look for a culprit. We began searching for a new kind of energy, some exotic fuel being injected into the engine of the cosmos. We thought, if something is pushing the galaxies, then that something must be a substance. We are used to forces originating from objects. The Earth pulls the moon, a magnet pulls iron, the wind pushes a sail. But the deeper we stared into the equations, the more terrifying the answer became. The culprit was not an object. The culprit was not some hidden radiation. The culprit was space itself. This is perhaps the most difficult idea to grasp in the history of science. We are used to thinking of space as a stage, an empty box in which the action takes place. The box is passive. It just exists. You can put furniture in it, you can take it out, but the box itself does not change. But Einstein warned us a century ago, space is not a void, it is a fabric. It can bend, it can twist, it can vibrate, and now we have learned that it can do something even more frightening. It can multiply. Emptiness is not empty. A vacuum is not an absence of everything. A vacuum is a bubbling cauldron of hidden energy. Physicists call it vacuum energy, or the cosmological constant. But let us call it something simpler, the cost of space. Every cubic centimeter of emptiness has energy built into it. It is infinitesimally small. In the volume of your coffee cup, there is less of this energy than in a single atom. But the problem is, the universe is vast, and the voids within it are oceans. And here's where the magic begins to break the human brain. Imagine you have a sealed cylinder of gas. If you stretch that cylinder, doubling its volume, the gas inside becomes thin, its density drops, the energy dissipates. That is logical. Split a piece of bread between two people, and each gets half. But dark energy plays by different rules. It does not dilute. The property of having energy is woven into the very fabric of space. If you take a piece of vacuum and stretch it to double its size, you do not have half the energy. You have twice as much vacuum, and therefore twice as much energy. Space itself generates energy, and that energy forces space to expand even faster, which creates even more new space, which contains even more energy. It is a self-sustaining cycle, a chain reaction. a virus that feeds on its own growth. To understand what this looks like for us, the observers, let us return to your living room. Sit in your chair, look at the television on the opposite wall. Between you, there are 10 feet of floor, a rug hardwood, a coffee table. All is quiet. Now imagine that dark energy has stepped into the room. The floor begins to grow, not move, not slide, but actually appear. Every second, between the molecules of the wood, new millimeters of space are born. The television has no wheels. It does not move from its spot. Your chair is also bolted to the floor. No force is pushing the television in the back, but you watch in horror as it recedes. First, it was 10 feet away. A second later, it is 15. Then, 20. The rug stretches and tears. The table that was right by your hand is suddenly out of reach. The room becomes enormous. The walls retreat beyond the horizon. You scream, but the sound does not reach the person across from you, because the air between you is expanding faster than the sound wave can travel. This is exactly what is happening to the universe. Galaxies are not flying through space like rockets. They are sitting in their places, locked in gravitational wells. But the space between them is inflating like rising dough. Billions of years ago, a great cosmic battle was fought. On one side of the ring were dark matter and gravity. They tried to pull everything together, to collect, to glue, and for a long time, they were winning. The universe was breaking. On the other side was dark energy, the force of the void that wanted to tear everything apart. But approximately 5 billion years ago, the tipping point occurred. The universe had expanded so much that there was simply too much emptiness. The accumulated energy of the vacuum exceeded the gravitational pull of matter. The scales tipped, gravity lost. From that moment on, we have lived in the era of acceleration. Dark energy is the dominant force in the cosmos. Look at the diagram of the universe's composition. All the stars, all the planets, all the gas, you, me, your dog. That is 5%. Dark matter, the framework we were looking for, that is 27%. And dark energy, 68%. 2/3 of reality is pure aggressive expansion energy. We are the minority. We live in a world that is not designed for construction. It is designed for isolation. Every second, as I speak this sentence, millions of miles of new space are born between us and the neighboring galaxy clusters. They are leaving. They are falling out of our reach. We look at the sky and see an old picture. Light needs time to reach us. We see galaxies where they were millions of years ago, but if we could see in real time, we would see them fade and disappear beyond the event horizon. This discovery changed more than just physics. It changed philosophy. We thought the universe was a home, a static, reliable mansion. It turns out the universe is an explosion. We live on the shards that are flying further and further away from each other, and there is no way back. But the scariest part is not that the galaxies are flying away. The scariest part is what happens next. If this force continues to grow, what will stop it from entering our home? What if one day, space begins to be born not between galaxies, but inside them, inside the solar system, inside your atoms? But we will speak of that final act of the play later. For now, we must accept the fact that we have built a new model of the universe, and this model is disturbingly elegant. On one side, the web of dark matter, which holds; on the other, the wind of dark energy, which tears; and in the middle is us, glowing dust, caught in the center of the greatest tug-of-war in history. Now that we have all the pieces of this puzzle, the invisible framework of dark matter and the explosive force of dark energy, we can finally take a step back. We can stop looking at individual fragments and try to see the entire picture. And what we see forces us to completely redefine the very concept of structure. For the entire history of astronomy, we have been obsessed with objects. We studied planets, stars, and galaxies. We looked at them as precious gems lying on black velvet. We thought the velvet was just a background, a passive, boring void whose only job was to stay out of the way while the stars shined. But the new model of reality tells us the opposite. The gems are not the main thing. The main thing is the velvet, and it is not passive at all. Let us return to the concept of voids. Those giant cosmic empties we mentioned at the beginning. Before, astronomers considered them just gaps in the data, boring zones where nothing exists. But now we understand. Voids are the dominant force shaping the face of the universe. Remember how dark energy works. It is born in the vacuum. The more void there is, the more energy it generates, and the harder it pushes. Inside galaxies or clusters, gravity is too strong. It suppresses this expansion. But in the voids, there is almost no gravity. An ideal vacuum reigns there, and it is there that dark energy goes mad. These black bubbles expand with incredible aggression. They grow like a tumor, pushing space in every direction. And what happens to the matter that gets in their way? It gets crushed. Imagine that the universe is not an empty room, but a crowded subway car at rush hour. In the center of the car stands a massive man who begins to aggressively swing his elbows, demanding personal space. This is the void. The people around him are gas and dark matter. They are forced to retreat. They back away until they hit the backs of other people who are being pushed by another giant from the other side of the car. Where these pressures meet, a jam occurs. People are pressed together so tightly they cannot move. This is exactly how the cosmic web is born. It was not a spider that wove it carefully pulling threads. It was the void that squeezed it out. Galactic filaments, these majestic walls consisting of billions of stars, are simply zones of compression, places where matter was driven by the expanding bubbles of the void. We live in the spots where the borders of 2 or 3 voids have met. To truly grasp this geometry, we need a metaphor found in every kitchen. Forget about space for a moment. Think about how your sink looks when you wash dishes with a lot of soap. Look at the soap foam closely. What do you see? You see hundreds of air bubbles. They are different sizes. They press against each other, trying to take up maximum space. The air inside the bubble, those are our voids. They are zones of high pressure striving to expand. Now look at the boundaries between the bubbles. Thin, shimmering films of water, the joints where one bubble presses against another. All the water in the sink is concentrated exactly in these thinnest films and in the nodes where 3 or 4 bubbles meet. Inside the bubbles, there is no water. All the liquid has been displaced to the boundaries. The universe is foam. It is cosmic foam on a giant scale. The water in this metaphor represents the galaxies. It is you and I. The air is the cosmic void, pumped up with dark energy. We live inside a thin, fragile film of water, squeezed between colossal bubbles of nothing. The Milky Way, Andromeda, the Virgo cluster, all these giants that seem like the centers of creation to us, are actually just drops of liquid sliding down the wall of a soap bubble. We exist only because the pressure of the void on the left has balanced the pressure of the void on the right. This created a thin corridor of stability where gravity could gather atoms into a pile. This changes the entire perception of the map. We used to look at the Sloan Great Wall or the South Pole Wall, giant structures of thousands of galaxies, and admire them as architectural masterpieces. We thought, look at how gravity built this wall. But now we understand. Gravity did not build the wall. Gravity only holds the debris. The void built the wall. It is not the wall of a fortress. It is the boundaries of a prison cell. It is a front line where the advance of the void was temporarily stopped by the counter-advance of another void. And this battle continues right now. This foam is not frozen. It is boiling. In the sink, small bubbles often combine into larger ones. The thin film between them breaks and two volumes of air merge into one. The same thing happens in space. Voids grow. They become more powerful. Dark energy is the air that someone is constantly blowing into this foam. The bubbles inflate. The films of water, our galactic filaments, are becoming thinner and thinner. The gravity of dark matter desperately tries to hold these walls. It works like surface tension in soapy water. It tries to pull the matter together to keep the film from popping. It is a titanic struggle. On one side is the gatherer, dark matter, whispering, stay together or perish. On the other side is the ripper, dark energy, screaming, get out, I need more room. We live in an era of balance. For now, the surface tension is enough. The walls are holding, the filaments are shining. Matter can still flow through these channels, creating new stars. But we see the trend. The bubbles are winning. In time, the voids will become so enormous and the films between them so thin that gravity will no longer be able to maintain their integrity. Imagine this process on a scale of billions of years. First, the thinnest threads break. Lonely galaxies, which served as bridges between clusters, find themselves isolated. They fall into the void, losing connection with the mainland. Then, the walls themselves begin to thin. The flows of matter dry up. The cosmic foam begins to dry out. We are used to looking for the hidden form of the universe in the arrangement of stars. We connected the dots drawing constellations. But the true form is the shape of the voids. If you want to see the face of the universe, do not look at the light. The light is only the outline. Imagine a photographic negative. White becomes black. Black becomes white. This is exactly how a physicist sees the universe. The real bodies in this cosmos are spherical voids, 300 million light-years across. And galaxies are just the dust that collected in the cracks between them. This cosmic foam model explains what has tormented scientists for decades. It explains why the universe looks so similar at all scales, why the distribution of galaxies is not random, why these strange flat pancakes of clusters exist. It is all the geometry of pressure. We are the inhabitants of the bubble's surface. Our world, our reality, is a two-dimensional film bent in three-dimensional space by the void. This realization brings a strange feeling, a mix of fear and wonder. On one hand, we feel our fragility. We understand that our solid galactic home is only a temporary effect of tension. On the other hand, there is a terrifying beauty in this. We are not chaos. We are the result of a perfect balance between the two greatest forces of nature. We exist on the edge of a knife. To the left, the abyss of expansion. To the right, the abyss of expansion. And we run along the thin path in the middle, held by the invisible hand of dark matter. And the most amazing thing about this system is that it is not static. It is not a frozen sculpture made of foam. It is a working machine. Something flows through these thin films as if through pipes. This entire structure is a giant transport system. And now we will trace exactly where all these roads lead, because if there are roads, then there is a final station. One of the most persistent illusions of human perception is the illusion of stillness. When we look at the night sky, it feels eternal and motionless. The constellations seen by the ancient Greeks have barely changed. The North Star still points the way home. We think the universe is a museum where the exhibits are placed behind glass, frozen forever. But this is an optical illusion caused by our own brevity. We live too short a time to notice the motion. To the universe, the entire history of humanity is not even the blink of an eye. It is a fraction of a second. If we could press a fast-forward button and speed up time 1 billion times, the static sky above our heads would explode with frantic movement. We would see that stillness is a lie. The universe is not a museum. The universe is traffic. Imagine you are looking at Earth from a satellite at night. You do not see people. You do not see cars. You see only streams of light. Long pulsating veins of highways connecting cities. Red and white rivers of headlights flowing endlessly. You understand, these lights are not just glowing. They are moving. They have a destination. They are carrying cargo. The cosmos is built exactly the same way. Those filaments of the cosmic web, which we described as the walls of soap bubbles, are not just boundaries, they are roads, gravitational autobahns laid across the abyss. Galaxies are the cars on this highway, and we, the Milky Way, are one of them. We do not hang in the void. We race. Right now, while you listen to this voice, our galaxy, along with the Sun and the Earth, is rushing through space at 1.3 million miles per hour. We are flying along an invisible track, and we are not alone. Beside us, in the neighboring lanes, fly Andromeda, the Triangulum Galaxy, and dozens of dwarf satellites. We are all part of one convoy. We are all caught in a single current. But who built this road? And where does it lead? Dark matter built the road. Remember our framework. Dark matter created deep gravitational gutters. For a galaxy to fall into such a gutter is like a car falling into a deep rut. Escaping is impossible. You simply drive where the slope leads. The entire universe is a giant transport system. It is a labyrinth of interchanges, bridges, and tunnels. And like any transport system, it has its small towns, its metropolises, and its dead ends. Let us trace our route. Our local group of galaxies is moving along a small tributary. We are merging into a larger stream, which astronomers call the Virgo cluster. It is a massive gravitational node. Thousands of galaxies have already arrived there. They spin in a frantic dance, merging with one another, forming giant elliptical monster galaxies. But the Virgo cluster is not the final station. It is only a layover, a regional hub. The hub itself is also moving. It slides along an even more powerful filament of the web, heading towards something truly gargantuan. Astronomers call this place the Great Attractor. It sounds like the name of a comic book villain, and in a way it is. It is a gravitational anomaly of monstrous power. We cannot see what is there because it is hidden from us behind the dust clouds of our own Milky Way. But we feel it pulling. It sucks in everything within a radius of hundreds of millions of light years. Rivers of galaxies, entire superclusters flow there like water into a drain. These are the cities of the universe. The nodes of the cosmic web, the places where the main highways of dark matter intersect. That is where the real life of the cosmos happens. There, the density of matter is off the charts. There, galaxies collide constantly. Trillions of new stars are born. There, black holes fatten up to the size of solar systems. And if the voids are the desert, then the superclusters are the shining, overcrowded metropolises that never sleep. This picture feels majestic. The universe works like a clock. Matter flows from the desert into the cities. Order triumphs. But here, our second player enters the game, the one who hates order. Dark energy. Imagine you are driving down a night highway toward a distant city. You see its lights on the horizon. You know it is 100 miles away. You step on the gas, but an hour passes and the city does not get closer. On the contrary, its lights are fading. You look at your navigator and you see that the road ahead of you is stretching. The asphalt beneath your wheels is multiplying. The ground itself is lengthening. You are driving at the speed of light, but the space is growing faster. This is the tragedy of modern cosmology. We see how this machine works. We see how dark matter builds roads, trying to connect everyone with everyone. It wants to gather the entire universe into one perfect glittering city. But dark energy destroys those plans. It stretches the map. It pushes the cities away from each other. Right now, many of the galaxies we see at the edge of the universe are already unreachable. Even if we boarded a ship traveling at the speed of light, we would never catch them. The road between us grows faster than we can drive on it. The cosmic web is tearing. The very threads where the traffic flows are being stretched to their limit. First, the transport network will become fragmented. Over time, dark energy will isolate the districts. Superclusters will become islands. The metropolises will remain, but the highways between them will vanish. Traveling from one city to another will become physically impossible. We live in a unique time. Right now, it is the golden age of cosmic logistics. The roads are still open. We can see our neighbors. We can study the structure of the web. But we are the generation witnessing the beginning of the end of this connection. The universe is turning from a single organism into an archipelago of lonely islands. Our local group of galaxies will stay together forever, bound by gravity. We will merge into one giant galaxy, but the rest of the sky, everything else will go dark. Other clusters will fly beyond the event horizon. We will be left alone in the infinite expanding darkness. When the astronomers of the future look into the sky 100 billion years from now, they will not see the web or other galaxies or traces of the Big Bang. They will see only their own stars. They will think their galaxy is the entire universe. A lonely island in a static eternal gloom. They will never know that there were once roads here, that life was once teeming here, that there was traffic. And this thought is more terrifying than any black hole. The thought that knowledge is finite, that the traces of truth are being erased. We are the lucky ones. We managed to see the machine in operation. We managed to glimpse the blueprints of this labyrinth before the walls collapsed. But if this machine is so complex, if there are roads, nodes, energy, and motion, then where are the drivers? Where are the builders? Where on earth is everyone else? We look at this grand mechanism, at these shining metropolises full of energy, and we hear only silence, static noise, no radio signals, no engineering megastructures, no movement that cannot be explained by blind physics. This leads us to the most uncomfortable question of all. If the architecture is so perfect, Why is it empty? Or perhaps the problem is not the emptiness. Perhaps the problem is how we are looking. We built a model of the universe from dark matter and energy. We explain the motion of galaxies. We think we understand the house itself, but we forgot to look in the mirror. We forgot to ask ourselves, are we even capable of seeing the inhabitants of this house? After all, if 95% of reality is invisible to us, then perhaps we are like blind kittens crawling across a library floor, thinking the world consists only of the smell of dust, never suspecting the existence of books. It is time to leave the physics of galaxies and turn to the physics of our own consciousness. It is time to ask, not what is out there, but who are we? Let us be honest. The statistics are ruthless. A casual viewer would have turned this video off long ago. Most people want safe background noise and simple entertainment. Depth exhausts them, but you are still here. This means you are one of the few who actually want the truth, no matter how cold it might be. We need to stick together in this ocean of digital junk. Joining our ranks is the best way to amplify our shared signal and to ensure you do not lose sight of this channel. And now, within this small circle of our own, we can afford to ask the one question that everyone else is too afraid to even say out loud. In every science, there comes a moment when the numbers stop being comforting and start being terrifying. We have built a model of the universe that looks like a perfect mechanism. We have seen the cosmic web, a giant transport network. We have seen the nodes, the cities where matter boils with life. We have seen the energy that keeps this machine in motion. And at this very moment, the perfection of the architecture gives birth to the loudest and most frightening question in human history. If this is a house, then where are the tenants? If this is a road, then where are the drivers? We look at this colossal structure, full of energy and movement, and we expect to hear the hum of civilization. We point our radio telescopes at the centers of these metropolises, into clusters of thousands of galaxies, expecting to catch a whisper, a stray fragment of a foreign broadcast. But in response, we hear only static noise, the hiss of cooling gas, the crackle of dying stars. The universe is silent. This silence is so deep and so thick that it feels unnatural. It is called the Fermi paradox. Usually, it is formulated simply: if there are billions of stars, why do we see no one? But in the context of our new map, the map of dark matter and energy, this paradox takes on a completely different, sinister tone. We used to think we did not see others because space was too vast, that we were separated by insurmountable oceans of void. But now we know the cosmos is connected. The roads exist. The structure is whole. So why is the road empty? Why do we feel as if we have wandered into a giant, glittering skyscraper at night, where all the lights are on, the elevators are running, the servers are humming, but is there anyone in the corridors? Perhaps the answer is not that no one is there. Perhaps the answer lies in our own pride, in our naive certainty that we are even capable of seeing the tenants. Let us conduct a thought experiment that may seem humiliating to our ego, but is necessary for understanding the truth. Imagine an ant, an ordinary forest ant, that has accidentally crawled inside the case of a working supercomputer. He crawls across the motherboard. What does the ant see? To him, it is just a strange landscape. He sees flat green plains of fiberglass. He sees black square mountains of microchips. He sees gold tracks looking like trails. The ant feels heat. He feels the vibration of the fans. If he touches the contacts with his antenna, he might feel the bite of electricity. The ant is a perfect observer. His senses do not lie. The mountains are real. The plains are real. The heat is real. But is the ant capable of understanding what is actually happening around him? Does he know that these gold tracks are not just trails, but highways where gigabytes of information fly at the speed of light? Does he understand that these black mountains are right now calculating the climate model of the Earth or processing millions of bank transactions? Does he realize the existence of the internet which permeates this space? No. To the ant, the concepts of information, code, software, and the internet do not exist. He has no sense organs to perceive it. He has no brain to grasp the concept of a virtual world. He sees physical matter, plastic and metal, but he is blind to the meaning of that matter. He lives in a two-dimensional reality of crawling while above his head, in a layer invisible to him. A planetary scale exchange of data is taking place. Now, look in the mirror. The ant is us. We are crawling across the surface of reality. We are made of ordinary baryonic matter. Our eyes, our telescopes, all our instruments are tuned to only one type of signal: light, electromagnetic radiation. We look for others like us, creatures of flesh and blood, who build radio towers and burn fires made of atoms. But remember the proportions. We are 5%. 95% of the universe is the dark sector, dark matter and dark energy. We call them dark, not because they are evil and not because they are the color black. We call them that because they do not interact with light. They are invisible to us. They are transparent. But what if, to someone else, they are tangible? What if the real life, the true civilization of the universe, is built not from our fragile, rare dust, but from the material that is in abundance here? Imagine a civilization that was born in the depths of dark matter billions of years ago. Their world is more complex, richer, and more stable than ours. They do not depend on temperamental stars that are constantly exploding. They live in the eternal, cold framework of the web. Their bodies do not reflect light. Their radio does not use photons. Their thought processes are based on gravitational fluctuations or interactions for which we do not even have names. We can look directly at them and see nothing but a void. We can be in the center of their metropolis, and to us, it will look like an ordinary gravitational distortion. We look for radio signals while they communicate through the very fabric of space. In this analogy, we are the ants on the server. We crawl across the motherboard of the universe, feel the gravity, the heat of the processor, see the stars, the LEDs on the case, and proudly declare, "There is no one here but us," because we do not hear the chirping of other ants. It is the ultimate degree of cosmic irony. We scream into the void, "Where are you?" And the universe around us hums, works, calculates, lives a most complex life, but on a frequency for which we have no receiver. We thought the Fermi paradox was a problem of distance, that other civilizations were too far away. But perhaps the problem is not in the miles. The problem is in materials science. Perhaps the universe is teeming with life, but that life considers us, beings made of glowing, unstable baryonic dust, to be something like mold on the walls of a majestic building, or, at best, a side effect of the machine's operation. Dust on the cooling fan. This thought is frightening. It strips us of our status as the pinnacle of creation, but it also gives a strange hope, because if this is true, then we are not alone. We are simply deaf, and the silence of the cosmos is not a sign of death. It is a sign that the party is happening behind soundproof glass, and we are simply not invited. But even if we are only dust on the casing of the machine, we have one advantage over the ant. The ant will never understand what a computer is. He will die in ignorance. We, however, thanks to our curiosity, have begun to suspect the existence of the internet. We have seen the shadows on the wall. We have felt the invisible framework. We have begun to understand that the machine is finite and that its operation has an expiration date, because even the greatest computers are eventually turned off, or they break. And right now, we are watching as someone pulls the plug out of the socket. There is an old philosophical puzzle. If a tree falls in the forest and no one is there to hear it, does it make a sound? But cosmology asks a more terrifying question. If the universe exists, but there is no one left to witness its past, did that past ever truly happen? We are used to thinking that knowledge accumulates, that time works in our favor, that our descendants, 1 billion years from now, will know more about the universe than we do. They will fly on ships powered by black holes. Their telescopes will be the size of planets. Their computers will calculate reality down to the last atom. It is logical to assume they will be wiser than us. But that is a mistake. The tragedy of our universe is that, over time, it does not reveal its secrets. It erases them. We live in the era of information leakage. Remember dark energy. It stretches space. It pushes galaxies away from each other. Right now, as you listen to this, millions of galaxies are crossing an invisible line that physicists call the cosmological event horizon. The moment a galaxy crosses that line, it disappears for us forever. The light it emits can no longer catch up with the expanding space. The road ahead of the photon grows faster than the photon can run. It is like a person running up an escalator that is moving down. If the escalator speeds up, the person will never reach the top. They will vanish at the bottom. Galaxies are falling over the edge of reality. We are losing their signal, and this process is accelerating. Right now, we see billions of galaxies. The sky is full of light. We see the cosmic microwave background, the echo of the Big Bang that proves how it all began. We see the entire history of the world written upon the celestial vault. But this window of opportunity will not stay open forever. Imagine a civilization that appears in our galaxy, which by then will have merged with Andromeda 100 billion years from now. This is an unimaginably distant future. The stars will be dimmer, resources will be scarce, but life will still be possible. The astronomers of the future will build their telescopes and point them at the zenith. And what will they see? Nothing, absolute, perfect blackness. By that time, all other galaxies will have flown so far away that their light will never reach Earth. The cosmic web will be torn. The filaments will have snapped. The local group of galaxies will remain the only island of matter in an infinite empty ocean of gloom. The cosmic microwave background, the thermal footprint of the birth of the universe, will be stretched so thin that it will become undetectable. The traces of the Big Bang will vanish. Think about what this means for the science of the future. Those future scientists will be smarter than us. Their technology will be perfect, but they will build an absolutely incorrect picture of the world. They will look into the void and make a logical conclusion. Our galaxy is the entire universe. It is static. It is eternal. It is surrounded by an infinite vacuum. There was no Big Bang. There is no expansion. They will have no evidence to the contrary. All the clues will have been destroyed by time itself. The history of the universe will be wiped like files from a hard drive. and they will never know the truth. They will live in an illusion of eternal loneliness, never even suspecting that once the world was full of motion collisions and fire. This realization brings a shiver. It means that you and I are privileged observers. We won the greatest lottery in the history of time. We appeared exactly now, not too early, when the universe was a white-hot chaos, and not too late, when it will become a cold tomb. We live in the golden age of cosmology. In that brief moment, by the standards of eternity, when the universe is transparent, understandable, and accessible for study, we see the web, we see the recession of the galaxies, we have access to the evidence. Let us use a metaphor worthy of this moment. Imagine the universe is an ancient, priceless book. In it, the history of creation is recorded, but this book is on fire. The fire of dark energy is devouring the pages. Every second, chapters describing distant galaxies burn away. The ash scatters, and it is impossible to restore the text. We are the reader who burst into the library at the moment the fire had already reached the binding. The pages are already turning black. The text is beginning to fade, but we still have time to read. We feverishly flip the pages, trying to memorize the plot, trying to understand the meaning of the story before the book turns to ash. Those who come after us will find only a scorched cover. They will think there was no story. But we know this places a strange responsibility upon us. We are used to thinking of ourselves as insignificant mold on a small rock. We say, the universe does not care about us. And that is true. Physics is indifferent to our feelings. But the universe needs us in one very important sense. We are its memory. We are the only witnesses. Without us, without an observer who can see the light of a distant star and understand what it means, all this grand architecture, all this complex mechanics of dark matter and energy would be nothing but a silent movie in an empty theater. Our role is not to drive the machine. Our role is to document its work while we still can, to record the fact of its existence before the light goes out. We stand on the edge of a cliff, watching as the bridges collapse into the abyss. Our task is not to save the bridges. We cannot stop dark energy. Our task is simply to say, I saw this. It was real. The limits of our perception are narrowing. With every day, the horizon becomes closer. The darkness advances, but while we are here, while our telescopes catch photons that have traveled for billions of years, we hold the line against oblivion. We are the keepers of the truth that the universe was great, and perhaps that is the very meaning we have searched for so long in the noise of radio signals. The meaning is not in finding someone else. The meaning is in being the ones who remember. All stories have an end, and the story of the universe is no exception. We began this journey with an attempt to strip the mask from reality. We wanted to know how this world is built, and now we know the truth. We know that the stars are only dust. We know that the framework is dark matter. We know that the engine is dark energy, and we know where this road leads. Physics is ruthless in its predictions. The machine of the universe runs on fuel that is not infinite. One day, trillions of years from now, this engine will stop. The last star will burn its last atom of hydrogen and go dark. Galaxies will fly so far apart that they will lose their gravitational connection to one another. Black holes, those final guardians of energy, will evaporate into Hawking radiation. An era will arrive that cosmologists call heat death or the big freeze. The universe will become cold, dark, and absolutely silent. Space will become a graveyard of photons where nothing will ever happen again. Time will lose its meaning because there will be no one to count it and no events to fill it. This vision of the future can lead to depression. It seems that all our efforts, all our struggle, all art, science, and love, all of it is meaningless in the face of the coming eternal night. Why build a castle of sand if you know the tide is coming? But let me offer you another view. A view born not from fear of the future, but from gratitude for the present. Look at the clock. The hand is moving. The heart is beating. The sun is burning. You and I are not at the end of time. We are at the beginning. We live in that incredibly short era when the machine is working at full power. Right now, the turbines are spinning. Energy is boiling. Galaxies are giving birth to new worlds. The universe is alive. It is breathing. It is full of color and possibility. The fact that it will not last forever does not devalue this moment. On the contrary, it makes it priceless. Gold is expensive precisely because it is scarce. Life has meaning precisely because it is finite. We spent this hour taking the universe apart, piece by piece, trying to find a hidden design in its construction. We, humans, are obsessed with the idea of an architect. We always want to believe that someone wise stands behind the blueprints, that someone built this web, tuned the gravity, and launched time with some higher purpose. We want to find the Father. We want to be told, you are not here by accident. You have a mission. But we searched every dark corner. We looked into the voids. We measured the expansion, and we found no one there. We found only the architecture. Cold, majestic, mathematically perfect, but absolutely indifferent to our fate. This machine has no driver. This house has no master waiting for us for dinner. And for many, this discovery is a disappointment. We feel like orphans in an empty house. But maybe, just maybe, we are looking at this the wrong way. Maybe the absence of a master is not a tragedy but a gift. Imagine you found a magnificent, empty palace. You walk through its halls. You admire the height of the ceilings, the strength of the walls. You shout, "Whose house is this?" But only an echo answers you. Does that mean the house is useless? No, it means the house is free. It means that you can be the one who turns on the lights. The universe built the stage. It set the scenery of galaxies. It turned on the light of the stars. But it did not write the script for the play. The script is written by us. We are the way the universe knows itself. Without us, without our eyes and our minds, all these billions of light years of the web would be nothing but a heap of stones and gas. They would exist, but they would mean nothing. Meaning is not built into atoms. Meaning is born in consciousness. We are the spark that turns dead physics into a living story. We have long considered ourselves insignificant. We are just ants on a small rock. We are dust. Yes, physically we are small. We are made of fragile baryonic matter, which barely exists in the universe. We are easily destroyed. The flash of a single supernova nearby could erase us in the blink of an eye. But look at what we have done. We, creatures who live less than 100 years, chained by gravity to a wet rock, have managed to reach with our minds to the edge of reality. We cannot lift a star with our hands, but we can weigh it with our intellect. We cannot stop time, but we can understand how it began. We drew a map of the invisible world. We calculated the weight of ghosts. We looked into the face of the abyss, and we did not blink. That is not weakness. That is greatness. We are no longer passive observers. We are beginning to understand the levers of control. We are learning to change matter. We are learning to create energy, like that of the stars. We are taking our first timid steps beyond our cradle. Yes, dark energy is tearing space apart. Yes, the horizon is narrowing, but while we have time, while the light shines, we will continue. We will explore this labyrinth. We will find every one of its secrets, and perhaps one day, millions of years from now, our descendants will become so powerful that they will be able to challenge even entropy. Maybe they will find a way to light fires when the stars go out. Maybe they will find a way out of this machine. But even if not, even if the finale is inevitable, the journey itself was worth it. Because in the cold, dead mathematical void, there is one miracle that breaks all the rules of probability. That miracle is you. The fact that you exist, that you are capable of thinking, feeling, and asking questions. We looked for meaning outside in the stars, but meaning was always inside in the observer. We are not guests in this world. We are its only hope for significance. So the next time you look at the night sky and feel the cold of infinity, do not be afraid. Smile at it, because the abyss looks at you with envy. It has time, it has space, it has power, but it does not have life. And you do. We accepted the challenge, we cracked the code, we saw the skeleton of the Leviathan, and now we know our place. We are the ghosts in the machine that was not built for us, but we have learned to take the wheel.